All right, so we this is a second class in June, and we're gonna have another class on 16. Then the semester is over, and okay. I got a request from a student asked me to discuss the following problem. It's a little bit. This is a kind of difficult problems. Okay. My question is, how many ordered but sorry. Let me erase it. Yeah, how many ordered pairs A, B, C, D, E? This is the last problem because coordinates of the value -1, 0, or positive. Okay, and satisfying the equation A plus B squared plus C cubed plus D to the fourth power plus E to the fifth, which is going to be 2. Now, before we do this problem, this is a complicated equation. It's hard to find all the puzzle solutions. You can find some, but it's not easy to find all of them. What I should know is if x is plus minus 1 and 0, then you will see that, or 0, then you get x. The other power is still the same as x. No need, there's no need because x cubed. Okay. Yeah. So that's not, when x is 0, that is 0. When x is when x is a 1, that's a 1. The 1 cubed is still 1. So no big difference. Okay. But if x is plus minus 1 or 0, then the even power is going to be absolute x. You cannot get it, but does not increase the value. That just drops the negative sign. Okay. So in other words, plus minus 1 cubed is going to be 1 and plus minus 1, but plus minus 1 square is always positive 1. Okay. So in other words, I can. This above equation is the same as A plus absolute B plus C plus absolute D plus E equals 2. If A, B, C, D, E only takes value of -1 and 0 or 1. Okay. So now then you see that these two are special. Okay. So you only have 2 type of numbers. Okay, so that's 2 type of numbers. Okay, you can still write. As B squared plus D to the fourth power, and here's A plus C cubed plus E to the fifth. Okay, no problem. Okay. So what is the starting point to solve the problem? I find out it's easy to handle these 2, okay? Because what is the possible value for B squared plus D to the fourth power? Well, the maximum possible value is going to be 2 only. And it could be 0, it could be 1. So B squared plus D to the fourth either 0 or 1 or 2. There are only 3 cases here, right? There are only 3 cases here. But the A plus C cubed plus E to the fifth could be -3 from -3 to from -3 to, from -3 to -2s, -1, 0, 1, 2, 3. Because if A, B, C are all equal to 1, it's possible just for them, right? It's hard to, it's just too many cases here. So I will prefer to focus on that first, okay? So case 1, I want to see when this is 0, okay? Then the equation is simpler. The equation is too long. You cannot handle this equation directly. There's 5 numbers there. But if you find out you can break into many 3 cases, then the equation is simplified, okay? So you have a plus cq plus e to the 5th equals 2, okay? And then those 5 numbers can be reorganized. There can be D and D here, and A and E, A and C and E, okay? Regroup it. So the first case, you can see that b squared plus d to the 4th power is 0. Then you find out this 2 must be 0, right? No problem, okay? It's clear, yeah. Then you just need to see how many choices for A and C and E, okay? So the sum is going to be 2, okay? The sum is going to be 2. Now, how to make it a 2, okay? You can, the only possible case is you have a two ones and 1 negative, okay? Or 1 0. Okay, so 1 plus 1 plus 0 is going to be 2. Okay, let's just assume 3 numbers, plus, minus, 1, plus, and a 0. How to make them to be 2? Okay, and how to make them to be 2? I think this is the only possible way to do that. 3 numbers in different order. Okay, if that's obviously, this is the easy case to see that, right? So you can, of course, A could be 0, C could be 0, E could be 0. So total, there are 3 possible ways to, right? So you get 0, 1, 1, or 1, 0, 1. And 0, sorry, 1, 1, 0, okay? So total 3. And then the case 2, okay, b squared plus d to the 4th. This is the most difficult one, complicated one, okay? When this is going to be 1, right? Then in this case, a plus e, that's also equal 1, right? So you needed to, find out, so dividing the 2 here, so left and right. You need to find how many possible solutions for B and D, then how many possible solutions for A and C and E, okay? So B and D is still an easy equation to handle. In order to equal to 1, one of them must be 0, other one must be 1, right? That's only 2 choices. So if B is 0, then D is a plus minus 1. If B is a plus minus 1, D is 0. So total, you have 4 choices here. Okay, it's a combination. Okay, so this is this equation is a little bit easier. The difficult part is a plus cq plus e to the 5th. How to find all the possible solutions. Okay, how to find all the possible solutions. Okay, and then you have 3 equations here, right? So a plus cq plus e, 3 unknowns. So it's not easy to do that. Then what you should do is you list them in 3 subclasses. So a equals -1, okay, because a can be 0, -1, and positive. Then cq plus e to the 5th is going to be 2, okay? And that's the first case. And then how many solutions you can get? The only possible solutions would be 1 and 1. Okay, so 1 and 1 is going to be a solution. Okay, so when a equals 0, CQ plus e to the 5th is going to be 1. Okay, so in this case, yeah, here you get one solution, right? You get the one solution. Okay, now in this case, how to get a 0, right? How to get a 1? Because C and the E possible value is only 1, -1, 0. So you only get solution 0, 1, 1, 0. Okay, so I have 2 solutions. I don't think one of them could be negative because one of them can never, the sum cannot be 1. Okay, so then A equals +1. Then CQ plus e to the 5th is going to be 0. Then you have more solutions here. Okay, you have more solutions here. First of all, 0, 0 is a solution, right? And the 1, -1 is a solution. And the -1, 1 is a solution. So you have 3 solutions. Total, you have 6 solutions here, right? So 1 plus 2 plus 3 is going to be 6. Okay, so you put the 6 here. So the combination will be 6 times 4, right? The combination here will be 6 times 4. So 4 times 6 is going to be 24 solutions. All right, the last one, case 3, b squared plus d to the 4th power is going to be 2. Okay, in this case, right? In this case, a plus CQ plus e to the 5th is going to be 0, right? So you still have B and D and A, C, E. You have to figure out how many possible solutions for the pairs of B and D, how many possibilities from A and C and E, right? So let's look at the first equation, b squared plus d to the 4th power. Okay, I think b can be ±1, d can be ±1. Okay, right? So then b squared plus d squared equals 2. So there will be actually 4 solutions here. That's 4. Okay. Now the trouble is this one. Okay, it's a 3 unknowns. The idea is still the same. Okay, the idea is you begin with it's too many numbers. That's difficult. So begin with -1. When a equals -1, CQ plus e to the 5th is going to be 1, because otherwise the sum is going to be 0. Then you know that there's only 2 solutions, 0, 1, 1, 0. So it's 2. Okay. Okay, 2. Okay. Then when a equals 0, CQ plus e to the 5th, I think it's a 0. Okay. For this one, we already know that how many solutions we did, right? So 0, 0, -1, 1, 1, -1, so 3. Okay. Then when a equals 1, the sum is going to be 0, so it's going to be -1. And for the -1, it's the same as like a positive one case. And 0, -1, -1, 0. So it's 2. So total is 7. 2 plus 3 plus 2 is 7. Then you add them together. You put a 7 here. 4 times 7 is going to be 28. Okay. So each case you figured out is a total possible total number of solutions. Then add them together. I think the first one gives you, the first one you have 3, 24, and 28, I think, yeah. The total number, right, is going to be, yeah, total number of solutions is going to be 3 plus 24 plus 28. Okay, so total is 55. There are 55 solutions. So that is the number on the answer key. Some students get some solutions, but never got, they didn't get all of them. Okay, so the idea is you have to divide. You have to give them a list of the several cases and trying to figure it out in each case. Okay, and there is a sub case also. If you have an equation with 3 unknowns, how do you find all the solutions, right? How to find the solutions. Now here's a similar problems. Here's a for instance problems here. Let's see. How many tuples of positive numbers A, B, C satisfying positive integer numbers, okay? Integer, okay? Satisfying A plus B plus C equals 50, for example, okay? So like this, how many triples A, B, C, right? So you get, you have 3 numbers, okay? But only one equation. But we know is that integers, positive integers, very important. So positive integers A and B and C, that cannot be too large, okay? But they also cannot be too, that can be 1, right? How do you solve this problem? Right, they're not uniquely determined. So the idea is that you figure out what is largest possible value for A, what is largest possible value for B and C, right? Let's say, just look at the A. The smallest possible value for A is 1, I'm pretty sure, right? A could be, A could be, A is positive, so it must be 1. But A cannot be too large. A's largest possible value for A is 48. So the reason is if A is 49, B and C cannot be positive because the smallest value for B and C is 1, right? 1, so 48 plus 1 plus 1 is 50, okay? So you have to look at each case. If you say if A is 1, then B plus C is going to be 49. And then you look at how many solutions B and C. It's the same, right? So if B equals 1, then C is uniquely determined at 48. Okay? If B is 2, then I just do the first problem. Okay? C equals 47. And keep it going. B is 48 and C is 1. Okay? So total, you have 48 solutions there when A equals 1. But when A equals 2, you will get 40. Let's see, you can get 47 solutions. Okay, because B could be 1, 2, all the way to 47. Then the corresponding value you can get a C. Okay, so 47, and just keep it going, right? When A equals 48. Then B plus C equals 2, then you only have 1 solution. Okay, when A equals 1, you have 48. When A equals 2, you get 47. Okay, so total number of solutions you are going to get is add all those numbers together. So the number of solutions is going to be 48 plus 47, 46, all the way to 1. Okay? Yeah. Then there are only finite many solutions there. Okay? So add them together. You know that there's a formula, 48 times 49 divided by 2. Okay? You can multiply this out. It's a pretty large number. Okay? Times 49. Okay? It's 1,176. Yeah. So this is a solution. Okay. Nope. You got different answers. David John says 976. Did I?
No, it is.
It is 1,176. Okay. So yeah, if you have 3 questions, 3 unknowns, 1 equation, if those are integers, you know they're positive, then this is the way we that's the way we do. And the problem we did it before, it's just a little bit more complicated than this one. The idea is that, right? All right. So now. All right, so let's go through all the all kinds of different type of problems, okay, today. So the first problem I want to talk about, it's a review, right? I hope you still remember that. So this is the cube. It's a cube, okay? I know that the diagonal D is going to be 5 inches. Okay, so what is the surface area? Of the cube? Yeah, it says cube, but we don't know the dimension. Okay, but we know the length of the diagonal. Okay, you will get an integer. Yeah, you learned the 3D geometry, right? That's in advanced class. So are you able to solve the problem? Yeah, Sophia. 50 square inches. Maybe right? Let's see. Okay. So how do you do that? Step by step. You know, when you do the homework, don't just work on the scratch paper. Okay? You have to write down the correct steps. Because keep telling yourself, this is the one I'm going to show to the teacher or to my classmates, so they should be able to understand what you're doing there. Okay, it's not just answer. You know, gradually from middle school to high school to college, we are going to pay more attention to each step of your solutions than just answers. Teachers in middle school, high school probably still too busy to grade the details of your work. So that's why they always give you multiple choice problem, you know, just answer. But we really want to know how do you should learn how to express each step correctly. Okay, and draw the picture, for example, right? You mark the D. So this is the edge length, right? So first of all, you write down the relationship between A and D. D square equals A square plus A square plus A square, which is 3A square, right? So that's a relationship between the length of the diagonal and the edge length. The surface area is going to be, each side is a square, so A square. But how many faces there? There's 6 faces there. Okay, look at this. You don't need to find the edge length. All you need to know is the A square. Okay, right? So D square is already know that D is 5, right? So from here, well, that's right. So 6A square, you already know 3A square. 3A square is 5 square. So 6 is going to be 3A square. So it's 3A square is D square is 5 square. That's why 50. So it's easy. That's the quick way to do that. You don't need to find the edge length. You don't need to say, you know, h is going to be square root of 5, blah, blah, blah. Square root of 3, 5 divided by square root of 3. So a is actually is going to be 5 divided by square root of 3. But you don't need to do that. This is not necessary. It takes too much time. So there's a quick way to do that. You see, look at the write down the relationships. You find out, I don't need to find the agent. I just need to find a square. Okay, a square is given. And actually, you just need to know what is 3a squared, right? 3a squared b squared. Okay, so the surface, and you can derive the formula also by yourself. You see, a good student will say, hey, I have a new formula. The new formula says that a, the surface area, is going to be 6a squared will be 3a squared is 2d squared. So the relationship between the area and the length of the diagonal, there is a direct relationship now. So this is a new formula you can feel, okay? And if you have a good memory, you can just memorize it, okay? So I want to see, you know, not only just solve the problem, you can also derive the new formula never mentioned in the book, then you're a super good student, okay? You have a potential, become a mathematician, okay? If you just solve the problem and step by step, oh, I find the edge length, and then that's a 5 over square root of 3, then I calculate the area of each square, then multiply by 6. That goes through all this long way to get the answer. Yeah, that's still so it takes more time. You have less time on the test then. Okay, so this is simple problems, but the short way to solve the problem. And if you find this short way, you should be able to derive this formula by yourself at the end. Okay, so there's a direct relationship between the length of the diagonal and the surface area. Okay. So next time, if I ask you, hey, if I know the surface area is going to be 200, what is the length of the diagonal, right? Right? That's another way to do. Then the surface area, yeah, if the surface area of a cube is 200 square centimeters, what is the length of the diagonal? Okay, then if you already know this is a 2d square, then you solve. Otherwise, you have to go through the edge length. Okay, so it's 200 equals 2 times d square, and d square equals 100. Then implies d is going to be 10. Okay. And those are the kind of problems usually on the countdown of mass countdown part. And some students answer the question within 10 seconds they get it because they know this link between the surface area and the length of the diagonal. Okay, the countdown problems, 45 seconds each time you're given. Okay, and then all the students sit within the large lecture hall, and there's a large screen on the wall, and then the problem will be projected to the wall, and there was a team, I think from each school, they have to put hands up and they have an answer. No, there's a ring, push the button on the ring. I was there at Purdue University a few years ago, and there the student did it very fast. Even the problems, you know, the teacher will read the problem loudly. When the teacher finishes reading, they already have the answer. Okay. Okay. So this is this is the first geometry problems. The second geometry problems is also a little bit tricky. Okay, I have the circle. Okay. And this is the center, O. Okay, so this is the triangle. It's triangles inside. So let me share it. All right. So the question is, what is the area? This side is 8. That's about 6. What is the area of the shaded region? Okay, express the answer in terms of pi. Okay, don't unless you ask it to estimate it. Okay, so the O is here. O is a center of the circle. Okay, O is the center of the circle. Oh, everybody got it? Right? That divides by 24. Okay, so to solve this problem, you have to know the radius of the circle. The radius is going to be half of the diameter. The diameter is going to be 10. Okay, so the radius R is going to be 5. The reason is that is important property you already used. If the triangle is inscribed in a circle, if the hypotenuse is the diameter, then this triangle must be the right triangle. Okay, so I'm going to talk about this later. Okay, so if you know this, then the area is going to be 5 square pi minus the area of the triangle. Okay, so it's going to be 25 pi minus 24. Now, what property you are using? If we have a circle, okay, if I have a circle, you have 2 points A and B. This is the center O. And first property, yeah. So you have triangles here. No triangle. The angle, 2 angles. If this is alpha, this is the beta, then beta is going to be twice of alpha. Okay? So this is the important property. Now the special case is you move A and B to form the special case to form a diameter. Okay, this is the O, and here's A and B. Okay. Then beta is going to be 180 degrees. Okay, and this is the alpha. Okay, so we know that alpha is going to be half of the beta, right? Which is 180 degrees. Divided by 2 is 90 degrees. That's the reason this triangle must be the right triangle. Okay, this must be the right triangle. The reason is because it follows from the general formula. Okay, it follows from the general formula. If the hypotenuse is going to be on the diameter, then the angle here going through the at this O is 180 degrees. So this must be the right triangle. If you use that property, then you can solve the problems. Okay. Yeah, this is a review of the formula. Okay. All right. So here's another tricky problem. So we have this what we have here is we have a square. This is a square. Okay. And what I'm going to do is square with edge length 20 feet. Okay. So what I'm going to do is I'm going to cut 2 feet. 2 feet. Okay. The same way, doing like that. 2 feet. 2 feet. Here, 2 feet. 2 feet. 2 feet. 2 feet. Okay. So what I'm going to do is I connect these 2 lines. Okay. So I build the path. So the remaining area will be the flower gardens. Okay. So this is This is a little bit tricky problem. It's easy problem, but you have to figure out how to do it. So my question is, what is the area of the shared region? After you build those two passes, okay? You know how to figure it, right? Yeah, total, the original square, the edge length is 20 feet by 20 feet. Okay, there's a direct way to solve a problem, there's a shortcut. The direct way to prove it is 4 triangles are identical, isosceles right triangle. But you have to, question, you have to find the area of each right triangle. Okay? Yeah. Sophia? 256. Right has different answers?
256.
Okay. 256. Right. So let's do the most general way. Another shortcut is you have to figure out this right triangle, right? This is another best way. I just said that, but you multiply by 4. Okay, this will be the right triangle. Okay, and this side is going to be 20 minus 2 minus 2 is 16. Okay, if an isosceles triangle, if you know the third side, then you can find the area. Okay, so the area is going to be, you see that it's going to be, this side is going to be 16 over square root 2. 16 over square root 2, because when I add them together, yeah. So the area of this tiny one is going to be half of the base as times the height, right? Divided by 2. Okay, so it's going to be 16 squared and it's 2 times 2. Okay, but you have 4 pieces there, so total area is going to be 4 times 16 squared, 2 times 2 is 16 squared. But there's also a quick way to do if you know how to play it with a puzzle. All you have to do is, after you remove those 2 passes, you push the 4 triangles together. To form a smaller right triangle. Okay, so if you push them together, you get smaller right triangle, and then that'd be much quicker way to solve the problem. So you gotta square again. Okay, you gotta square again, then what is the area, right? Then that's the most quick way. So 16, 16. So the area is gonna be 16 squared. It's the same. You don't need to find the area of each isosceles triangle. Okay, so that's the quick way to do. But you can also find the area of each isosceles triangle. Okay. All right, so let's go over some other problems. I hope we can do that. All right, so we have this is the counting problems. A radio station use 3 or 4 their call. Yeah, we did it from before, maybe color numbers, color letters. Okay, the first letter must be A or a B. Okay. So how many different color letter string are possible if no letter may be repeated within a string? Okay, so you have to divide them into a couple categories. Okay, so a typical example is A. Must begin with A, right? And A, C, D, for example, right? Another one could be A, C, D, E. You can also have a begin with a B, B, C, D, B, C, D, E, for example. Okay, this is just an example. The questions, all the letters must be different.
Is it 28,000? Yes, 28,000.
28.
28,000.
Yes, yes. Yeah. So you figured out in each group, okay? It's repeated. So as long as you can figure out this, then you can multiply by 2. You can get all of them, right? So there's 2 groups, A star star. Another one is A star star star, right? Right? For begin with the letter A, right? And how many letters there are? 20. So you have a 26 letters. So for the first one here, you have a 25 letters you can use because the A is already used. Then for the last one, you only have a 24 letters you can use because 2 letters already used. So total will be 600. Now for the next one, you begin with 25, and then for that one, you have a 24 choices. For the third letter, you have a 23 choices. See, there's 3 different letters, right? How many possible combinations you can have? And how do you do that? You step 1, you pick up 1 letter from the group. But the A is already used, so you can only select from B to the last one, Z, 25 choices. Then you select the next letter, but which you only have 24 choices now. Then you select the third letter, 23 choices. So the total possible combinations will be the product of those numbers, which is 13,800. So total will be 600 plus 13,800, and you have to multiply by 2. The reason is you have another group of color letters. Okay, so add them together, you get 28,800. Okay, so this is the total number. All right, so let's look at the next problem. We have several equations. Suppose that C plus D equals 3, D plus E equals 4, C plus E equals 8. Okay. Find the value A, find the value C, D, E.
What?
Find the C, D, E, the product of the 3 numbers.
Is it 40?
No. It's a fraction. Yeah, those called the symmetric equations. You have to use the property of the symmetry of this equation. Kind of, we see C plus D, D plus E, E plus C, right? Yeah. Yes. Yeah, you use a, some problems you can find the product without finding individual value. For this particular problem, we may have to find the individual value first, then multiply them out. But that's not difficult because you have a three nice equations. Because those three nice equations, sometimes the question is like, what is the average value of those three numbers? Those are the problems for the basic math class, okay? And now you have to find ACE times CD, right? So what you do is that you add them together, and then you get C plus D plus D plus E plus C plus E is going to be 3 plus 4 plus 8. So twice of C plus D plus E is going to be 15 here, right? So C plus D, you only find the sum, but that's okay, find the sum, because once you find the sum, you can find the individual value quickly. Why? Because you already know C plus D, right? C plus D is 3, 3 plus E equals 15 over 2, right? And D plus E, then from here, C is going to be 15 over 2 minus 3, and then 3 over 2. Then you also use the same equation, D plus E. If D plus E is going to be 4, right? Yeah, D plus E is 4, then you replace it. Then you get, wait a minute. I'm confused. This is the E, okay, that's E, okay. Yeah, C plus D is 3. D plus E is 4. Then C is going to be 15. 15 minus 8, 7. Okay. Then the last one, C plus E is 8. C plus E is 8. 8 plus D is given, right? So that gives you D. And that is going to be -1/2. Okay. So you get the individual values, just multiply them out. Am I right? And let me double check my computation. No, I think this is 6. No, that's right. Yeah, so then add them together. ECD is going to be 9 over 2, 7 over 2, -1/2. So it's -60, 63 over 8. All right. So to find the individual values, you just need to find all of those. Yeah, right. So sometimes you ask it to find what is the average value. If you know the three equations, the average value of C and D, and the average value of D and E, average value of C and E, then you find the average value of three numbers. But for this particular problem, you have to find each individual value in order to solve the problem. There are similar problems like that. Let me ask it. We did it before. I hope you still remember. So suppose you have a rectangle, right? This is a rectangular box, right? So if you know the area of each faces, okay, then like this is going to be 3 square centimeters, 2 square centimeters, 4 square centimeters, right? So what is the volume? Yeah, this thing. Can you remember that? Yes. Square root of 24. So yeah, simplify the 2 6. But so you label it, it's A and the B and the C. So what you get is A and the C is going to be 3, B and the C is 2, and the A and the B is going to be 4. Okay? Yeah. So you label each side. There's 3 different ages there, A, B, C. But you don't know what is A, B, C, right? But you can find A, B, C, right? So then, if I ask you to find each individual value, that's fine. All you have to do is not add them together. This time, multiply them together. Okay? So AC, BC, AB is going to 3 times 2 times 4. Okay? So this is 24. Okay? But the AB, BC, and AC is going to be ABC squared. Okay? Since we already know ABC must be positive, so ABC is going to be square root of 24. But if you do not multiply them out before, then you probably can quickly get out the 4, right? It's 2 square root of 6. Okay? So this gives the volume already. But if you want to find the individual value, you just divide, right? If you divide by, if you want to find an A, you have an A, B, C divided by B, C, right? And which is going to be 2 square root of 6 divided by B, C is 2, so square root of 6. So you can find the individual value of each, okay, if you want. Then you can find the other information. So what is the length of the diagonal, for example, right? For the same problem, not only just find the surface, find the volume, you have to find the length of diagonal. Then you have to find the individual value of each side. Okay? Yeah. Okay. But it's a similar idea. You do, if I ask you to find what is the volume and what is the length of the diagonal, if you have to find the length of a diagonal, and then you have to find each side, right? So A and the B is the ABC divided by AC. What is AC? AC is 3, right? AC is 3, so it's going to be, now you cannot simplify. And then C is going to be ABC divided by AB. What is AB? Let's go back. AB is going to be 4. So you simplify a little bit. Okay. Then those are the bad numbers, but if you look at the length of the diagonal, right? So we know that D squared equals A squared plus B squared plus C squared. Yeah, add them together. Yeah, do you remember how to get it, right? So this is the X and A and the B and the C. So first we get X squared plus C squared, and the X squared is A squared plus B squared. So then D squared equals A squared plus, okay? So then just add them together and simplify, and then you get the total length. Okay, 6x squared can take it out. You don't need to keep it. It's 1 plus 4 over 9 plus 1 over 2. And then this is just 6, right? And it's 1, 18. 18 plus 8 plus 9. Yes. It's not too bad, okay? It's going to be 6 times 36 over 18. So D is going to be square root of 6. No, this. 27 plus 8. 27 plus, sorry, 27 plus 8 is 35. Okay. So 35 is not divisible by 3. So this is that D is going to be square root of 35 over square root of 3. That's it. You can simplify a little bit further. All right. So let's move on to the next problem. Yeah. The ping pong balls are stacked in a pyramid with a square base and with one ball in the top layer. One ball in the top layer. So each ping pong ball rests on the 4 below it except in its base. Okay, so here's a question. Okay, we're going to, this is the type of pyramid. Okay, and throw the ping pong balls. Yeah, just one by one, imagine. Okay, so each ping pong ball rests on the 4 below it except for the base. Okay, so basically you have a 4 below that, then you put another one on the top. Okay, so this is the idea. Okay, how many ping pong balls are needed to build a tower 10 layers high? So sometimes maybe you go to supermarket and you see all the oranges are stacked together like a pyramid. Okay, so you first put a square at the bottom, and then layer by layer, But each time the number of the oranges is decreased by 1 each time, right? On each side, if at the bottom, if they are the bottom, I think the bottom part is going to be 10. So, right, at 10, 10 on each side, right? And then decrease, each time decrease by 1. So 10 layers on the top there's 1 there, right? So you have to begin with a 10. 10 by 10. Okay, so 10 rows at the bottom. Each row have 10 ping pong balls. Okay, then the next one will be each row contains 9 balls, then 8 balls, and 7 balls. Okay, so just add them together. But you do need a formula for the sum of this perfect squares, because total number of the ping pong balls in each layer is a perfect square.
Is it 385?
385. All right, so the sum is going to be, the very top one is 1. The second one is 2 squared, that's 4 there, right? Then 3 squared, then 4 squared. I hope you still remember the formula for this. All right. If you remember this formula, then it's easy to solve it because 1 squared plus 2 squared plus 3 squared all the way to n squared is going to be, first of all, you have this formula. Everybody knows that. It's going to be n times n plus 1 divided by 2. But the second formula will be n times n plus 1, 2n plus 1 divided by 6. Okay. And I have one more formula I want you to memorize. Is going to be n times n plus 1 divided by 2 squared. So those are the 3 formulas. Using one of the formula, it's going to be 10 times 11 times 21 divided by 6. Now, after you simplify, it's going to be 385. So there'll be 385 ping pong balls there to form the pyramid. Okay. Okay, so those are the 3D geometry problems. Now, I hope let's go back to the probability problems. Okay. So cards are randomly drawn once at a time without replacement from a standard deck of playing cards. What is the probability that the first 3 cards chosen are clubs? Okay. Without replacement, okay? All right, so there are total 52 cards among them, and among them are 13 clubs. Okay, so we have so this is there are 52 cards. Among them are 13 clubs. Okay, so this is the this is the fact. Okay. Then what is the probability to get in the first 3 clubs? Anyone online can give me the answer? David, I know you can do it. David John. Edward? Oh. You don't need to give me the fraction. You don't need to divide, okay? Just give me a simplified fraction. Kelly. Can you simplify 33 over something?
Here. 11 over 30. Sorry.
11 what?
Or 850.
850. Okay. All right. So first of all, what is the probability, right? Probability is going to be the number of all possible outcomes. That is in the denominator. The numerator is the number of design outcomes. Then when you select 3 cards one by one, right? 52 cards there. So 52 cards, select one by one. For the bottom part, you have first of all, you have 52 choices. Then the 51 cards left. The next step, you get 51 choices. Then 50 choices. Okay. So that's a total number of, you put it in a row, right? This is the total number of possible outcomes. The first one, second one, third one, because we do need to know the order. Okay, because in the question, they say the first 3 cards, right? First or second, third. But for the numerator, you only consider the clubs. So there are 13 clubs. So when you pick up 3 cards, the number of desired outcomes will be, first of all, you have 13 clubs you can choose. Then next step will be 12. Then 11. Okay, this is the number of all possible outcomes. The first 3 cards are clubs. Okay, then you simplify. Okay, don't multiply them out immediately. Okay, then you after you simplify, you get actually 20. Yeah, 13. Yeah, you can get rid of that. 13 and 12. So it's 11 over 850. Okay, so this will be the simplifying the formula. Okay. So if you know how to do counting, then you know how to do the probability problems. That's why we have a chapter before that about counting. Okay. Yeah, let's look at another probability problems. Okay. Randomly select choosing 2 numbers from the set 1, 3, 5, 7, 9. Okay, was replacement. Now this means it's not; those are not objects. It's just a pure pickup, and you just write down the other numbers. Okay, what is the probability that the product is greater than 40?
What do you mean with replacement? What do you say?
You can repeatedly using those numbers.
Oh, okay.
Greater than 40.
40?
Okay. Okay, so you have to, was a replacement, and choose the 2 numbers. So you write down 2 numbers, right? So independent 2 numbers. So just look, let me finish the denominator, okay? So the number of all possible outcomes. For the first digit, you have 5 choices. Second digit, you also have 5 choices. So in total, the 25 numbers you're going, 2-digit numbers you're going to get. Then you have to figure out all the other possible combinations, which gives you a product greater than 40. Okay, so there are 6, right? There's 6. Okay, so you figure out 5 times 9 is 45. Then this also should be the order, 9 times 5. Okay, and 7 times 7 is 49. And another possible way is 7 times 9 is going to be 9 times 7, 63. And what else? Also 9 times 9, okay? 9 times 9 is going to be 81. So those are all greater than 40. So total is 1, 2, 3, 4, 5, 6. So 6. That's it. So 6, not 20. It's not 4 because we see that 5 can be first, 9 can be second. Also 9 first, 5 second. Okay. Okay. So this is the way we got this. Well, there's one more problems. I'm going to finish class. Okay, the next problem is we go back to the equations. How many ordered integer triples A, B, C have the following property? This property that each number is a product as a 2. Each number is a product of a 2. So that means A equals BC, B equals AC, C equals AB. Okay? So 0, 0, 0 is going to be a solution. The trivial solution let me give you. This is going to be 0. Okay. Okay, 1, 1, 1 is also a solution. Now, can you figure out all the possible solutions? Okay. How many of solutions, Sophia? You get an 8? No. Eight. All right, so 0, 0 is giving me a solution. Okay. Let's look at the possible value for A and B. Right? I think the possible value for A and B, you can multiply them out, right? Then A times B times C is going to be, if one of them not going to be 0, then the rest of them is not going to be 0, okay? So they are either all equal to 0 or no one of them 0. So you can try different ways, like A, B, C, and the BC times AC times AB, and that is going to be ABC squared, right? So from here, you can clearly get either ABC 0, right? If one of them 0, you can figure out the rest of them 0, okay? Okay, so the first case, ABC 0. That implies A equals B equals C, because you know why? You just assume A is 0. Then if A is 0, then from the above equation, B, C are 0. Okay, so that's the second case. A, B, C is not going to be 0. then A times B times C must be equal 1. Okay? If it's equal to 1, okay, the chicken says we're in the class. If it's 1, all right, then you see that A, B, C cannot be, yeah. Then A square equals A, B, C, right? A square is going to be A times B times C, so it's going to be 1. And the B square is B times AC, right? Yeah, because B equals AC, so it's also equal 1. So C square equals C and AB, okay? So that is going to be 1. So A, B, C are really not arbitrary numbers. They must be plus minus 1. Okay, but then you conclude that, oh, maybe there are 8 solutions plus 1 is 9, but not all of them satisfy the equation. So you have to carefully choose those solutions. So we're almost there, okay? So actually, then you go back to the equation, but there are only 8 choices there. You go back to the equation using this star, okay? You go back to using this star, then you can see that there are not many solutions. And the first set, I think we get the first set, the 1, 1, 1, then 1, negative 1, negative 1. Another set of solutions, negative 1, 1, negative 1, and negative 1, negative 1, and positive 1. Okay, so you only have 4 solutions plus 1. So there are 5 solutions total. Okay, so that's it. So let's stop here. Okay.